Hello everyone, I'm Ramani from ECA. Today I'm gonna discuss with you about homogeneous equations and earth science. I'll go with this briefly. Next slides. Introduction to homogeneous equations. Homogeneous equations are mathematical expressions where all terms are of the same degree. In earth science, these equations helps model various natural phenomena effectively. Understanding these concepts is essential for analyzing physical systems in geology, meteorology, and hydrology. So, homogeneous equations means there are some kind of mathematical expressions. All the terms will have same degree in that homogeneous equations. So in earth science, these equations will help, but in various natural phenomena. These concepts is useful to analyze physical systems in geology, meteorology, and hydrology. Definition of homogeneous equation. Homogeneous equation is one where each term is a function of the same variable or set of variables. These equations can be linear or nonlinear depending on the nature of the relationship modeled. They often represent physical laws or principles governing Earth systems such as conservation laws. Here we can see that the homogeneous equation is one where each term is a function of same variable or set of variables. This can be linear or non-linear or depending upon the nature of the relationship model. They often represent physical laws or principles governing Earth systems such as conservation laws. We may have heard about many conservation laws and they often represent physical laws or Earth systems of conservation laws. So basically a homogeneous equation means each term is a function of the same variable or set of variables. Applications in geology. These are also used in geology applications. Homogeneous equations are used to describe processes like rock deformation or fluid flow. They help in modeling the stress and strain relationships in Earth's materials under varying conditions. Homogeneous equations also play a role in simulating tectonic movements and fault behavior. Basically, in geology, homogeneous equations are used to describe processes like rock deformation and fluid flow. They help in modeling the stress and strain relationships in earth materials under varying conditions. Means they can also use it to help to identify the stress. Means how the rocks are formed with how much stress they are sorry, with how much stress they are dealing in formation of rocks and strain in relationship between earth materials under varying conditions. Homogeneous equations also play a role in simulating tectonic movements and fault behavior. Application in meteorology. Meteorological models often use homogeneous equations to describe atmospheric dynamics. They are used to identify or analyze the atmospheric dynamic conditions. These equations helps in predicting weather patterns by modeling pressure, temperature, and wind fields. As we can see here, they use it to predict weather patterns and modeling pressure, temperature, and wind fields. They are crucial for understanding phenomena such as cyclones and anticyclones in the atmosphere. They are very crucial to understand phenomena. The basic things are predicting weather patterns, modeling pressure and temperature. They are basic, but here predicting cyclones, anticyclones in atmosphere is very crucial to understand using homogeneous equations. Application in hydrology. In hydrology, homogeneous equations are essential for modeling water flow and pollutant transport. They are used in simulating groundwater movement through aquifers and surface runoff in watersheds. These models assist in predicting flood events and managing water resources sustainably. So, In hydrology, homogeneous equations are essential for modeling water flow, means with in which direction water will flow nicely with balanced atmosphere and pollutant transport and groundwater movement, runoff watersheds, etc. These are useful. These models assist in predicting flood events and managing water resources sustainably. They also help us to predict flood events like um, to predict flood events and managing water resources to manage good water resources and everything. These are useful. These applications are useful in hydrology and mathematical formulation. For this, the mathematical formulation is given below in picture, and the homogeneous equations can be expressed in general form ax plus by plus cz equals to 0, where a, b, c are constant. This is the general equation of a homogeneous equation. Solutions of these equations are often found using methods such as substitution or elimination. Yeah, we can also use substitution and elimination, common methods to find out the equation. The nature of solutions can vary based on the number of variables and constants present. Numerical methods for solution. Numerical methods such as finite element analysis are commonly used to solve complex homogeneous equations. These methods allow scientists to approximate solutions where analytical solutions can be infeasible. Computational methods models helps visualize and predict behaviors of Earth systems under different scenarios. Here, numerical methods of solutions means such as finite element analysis are commonly used to solve the homogeneous equations, as well as computational methods used to predict the Earth systems under different scenarios. And some of these methods allow scientists to approximate solutions where analytical solutions may be infeasible. These are the things. And we can go to the next slide. Limitations and challenges. While homogeneous equations are powerful, they can oversimplify complex systems in earth science. Real world phenomena often involve non homogeneous factors that require additional modifications. Understanding the limitations of these models is essential for accurate interpretations and predictions. Homogeneous equations are they can oversimplify case studies. Numerous case studies demonstrate the effectiveness of homogeneous equations in earth science research. Examples includes modeling the stability of slopes in landscape, landslide studies, and groundwater contamination scenarios. These studies validate the use of mathematical models in addressing real-world environmental issues. Conclusion and future directions. Homogeneous equations remain a fundamental tool in the earth sciences for modeling various processes. Ongoing research aims to integrate these equations with non-homogeneous factors for improved accuracy. Future advancement in computational techniques will likely enhance our understanding of earth systems through these models. We can see case studies here first. Numerical case studies demonstrate the effectiveness of homogeneous equations in earth science research. There are examples including modeling the stability of slopes in landslide studies and groundwater contamination scenarios. These studies also validate the use of mathematical models in addressing real-world environmental issues. These studies also validate use of mathematical models and addressing the real-world and environmental issues means using mathematical expressions, mathematical formulas, mathematical equations to predict environmental issues or environmental related things is very common, and these applications are useful for that. And here we go about the conclusion and future direction. So, how we can see that homogeneous equations remain a fundamental tool in earth sciences for modeling various processes. Ongoing research aims to integrate these equations with non-homogeneous factors for improved accuracy. Future advancement in computational techniques will likely enhance our understanding of earth systems through these models. And we can see here the glance homogeneous equations definition first. Homogeneous equation is one where each term is a function of the same variable or set of variables. These equations can be linear or non-linear or depending on the nature of the relationship modeled. They often represent the physical laws of principles governing the earth system such as conservation laws, and we can do things like this and this. Thank you.